with joins with using clause. What is using clause in a join? We have uh, earlier we have you created all kinds of joins, right? What was the syntax in that? Like this here. Select. Where is? Yeah. So say this is a join, right? What we are doing, we are selecting the columns from table 1, and then what kind of join it is, then table 2 on. We are using on keyword for the condition, right? Now in case of using, what will be done is, I probably have that. Yes. So using is used in case if you are joining the same column. I mean, the name, data type, everything is the same. Okay. For example, uh, we're joining the table on the same column name. We can use the using clause to join. For example, okay. So we are here. We are joining employee and department. Okay, and it is always a there are no outer joins here. Why? Because can you see this using clause? Okay. What it means is this column country underscore ID is present in the same name. Same column name is present in both in employee and department. Okay. So sometimes, okay, like what we say, right? Our employee department structure, right? Employee table and department table. So I can probably show you that. Okay. So select star from emp. So employee table has, okay. Okay, okay. What is that command? Mm-hmm. Mm-hmm. Okay. I have never worked with SQL Plus, so let's start from EMP. Oh, good. So this is our employee table. Select star from depth. This is our department table. Okay. Now the columns in the employee table is emp ID, salary, emp name, dep underscore ID, mgr underscore ID. And from department, we have dep underscore ID. So you can see that the column name, okay, dep underscore ID is this is existing in both the tables and with the same data type. It might happen that in some other combination of tables, there will be a column, but it has to have the same data type. That means the identical data has to be there, right? So in this case, if we have to join, we can use, instead of saying that select uh, e dot emp id d dot, both both both. Okay, only then we can use the using. I'm just giving you the example. Okay, so we are selecting emp id from the employee table and department name from the department table. Okay, from EMPE. Yes, yes, I'll show you. I'll show you. Join dep D on. What was our original this thing syntax? Inner join on E dot dep underscore ID equals to D dot dep underscore ID. This is how we were doing earlier, right? Something happened. Uh, oh, okay, okay, yeah, yeah, yeah. Got it. I got it. I got it. Yeah. D dot. Okay. Emp E in a join dep D on E dot dep ID equals to D dot dep ID. Now this is correct. Yeah, this should give us data. Okay. So this gives us the join, right? Okay, instead of dep ID, we could have got dep name, but that doesn't matter. But the same query we can rewrite as select e dot emp id d dot dep name from empe join depd using just use, which is the common column here, dep underscore id. So that also works, right? So you understood the difference. So obviously this is a little bit of advantage in the syntax, in the framing the sentence, right? If you have, you don't have to do all this e dot dep id equals to d dot dep id, all that conditions you don't have to give. If you just say using dep underscore id, notice here that we are not giving any table alias to this column, right? That means this column is present in both the tables. Okay, so in only in those cases you can make use of this using clause while creating a join. Okay, and you don't have to mention inner join, outer join and all, just join. Outer join, I think outer join will work, but the basic concept is that using clause cannot be used everywhere. It has to be used, it can only be used when in the two columns, in the two tables that you're joining, there is one absolutely common column. Name is same, data type is same. Okay. So that was about joins with using clause. Then there was something in the grouping, sorry, in the group by clause, when we are using grouping in a query, how can we make use of count and distinct? You understand count, distinct? Select count of emp id from emp. Will give you a count. There are count 5 emp id. Okay, let me insert some more data values. What is there in just department ID, name, count. 2. So you understand, right? Count, what it does, it just counts the number of rows. Now we can make a combination of count and distinct also. You understand distinct? Select distinct. Uh, okay, so select distinct. If I say dep ID from emp, it'll only give me the distinct dep IDs that are there. Although we have 5 or 6 employees, these are the only distinct dep ID values in the employee table. Understood? Pretty simple, right? There is only one guy in department ID 2 and there are four guys in department ID 1. Okay. But the interesting thing here is we can, okay, when we use a group by, right? Select dep ID from emp group by dep ID. What are the thumb rules while using a group by? That all the columns in the select clause should be used in the group by clause, right? You cannot say select dep ID underscore emp ID. Yeah. Will this work? Dep ID underscore emp ID from emp group by dep ID. Will this work? Okay. But if I say count of, this will work. Okay. So here, so this is what, you know, implicit grouping functions do. Okay. So count is a aggregate or a grouping function, and it counts. We are accessing the employee table here. So for every department, how many employees are there? It counts and shows you, right? Similarly, distinct will also work. Okay, so that's the good thing about. So you can use max, salary also you can use, right? Say select ID max of, what is that column? Sal or salary? Sal. Max of sal from emp group by department ID. So it is going through the whole table, grouping by department ID, and within the department ID, it finds out the maximum salary. Okay, so there is a different value for department ID 1, there is a different value for department ID 2. Okay, clear? Yeah, so this is also done. Then we wanted to check the merge statement, right? What's a merge statement? It's very interesting. Actually, merge statement is very interesting in theory, but as I think I mentioned to you, right, in all these years of working in Oracle, I have never had to write a merge statement in my in the real time. Okay, because it's prone to a lot of error. Anyways, but it's a very interesting Oracle construct. Now, what are the basic DML statements? Insert, update, and delete, right? Merge statement is another DML statement. It is a DML statement. This can be best explained by performing an insert and an update at the same time. So in one statement, we will both insert into a table as well as update that very same table. Okay, that is in one statement. How? Let's let's check this. Let's use our okay. No, we cannot. Okay. Yeah, yeah, I will explain. Wait. Okay, fine. Let's just, I'll first explain to you. Okay, let this be there. So this is how it works. Merge into, that is the keyword. This is my destination table. Okay. When you update or insert into a table, you write insert into this or update table this. So that is your destination table. Here, destination table is employees E using. Okay. So you need another table. This is another table. Okay. That is a source table. So this is destination table. This is source table. On. This is the common, I mean the link, right? E underscore ID. That means ID column in employee and emp ID column in the HR records table. That is your link. So you can, maybe there is the primary key foreign key relationship over there. Okay. Then it becomes interesting. When matched, what do you mean by when matched? That means it does find a value which is there in both the tables, which is present there in both the tables, right? So that means now basically this is my source table and this is my destination table. So first it will pick the data, first it will pick the empid value from HR record and then search in the employees table. Does that employee ID exist already in the employees table? Then if it does, then it updates, right? Understood. I mean, if the data, if the employee is already there, basically what we are doing is we are updating addresses here. Okay. So if the employee is already existing, I update. If the employee is not existing, I insert a new row. Okay. So the whole statement is called merge, but you can do insert and update both in the single statement. So this is a single statement. Okay. So this will what this complete statement will do. It will first, I mean, it will row by row. It will go through the HR records table and then keep on comparing the individual IDs. What ID? Emp ID with the individual ID in the employees table. Then for the first value, if it matches, that means if the em- uh, emp ID exists already in the employee table, then it updates the address. If it doesn't, then it inserts a new row into which table? Good. So that is what is merge. Okay. There is another way of writing this. What is different here using? Okay, yeah. So here, instead of using the whole table, we can. So our source can be a query also. It doesn't have to be the table always. Okay. So only difference between first case and second case is what? Here we were using a table. We want to update only for guys who here what is this? Start date, add months, is it? Okay. So only guys who have joined in last month. Okay. For guys who have joined the company only in the last month. So for them, sorry. Yeah, add months minus one means you go back one, right? Add months function, you remember, right? We have discussed add months. Exactly 1 month later, right? But if I give the value, if I give minus one, it'll take you back exactly 1 month. So if it is 1st of January today, this will give you 1st of December previous year. Okay. So it's the same thing. So the basic difference between this statement and this statement is we don't have to have our destination as a table. We can use a SQL query for that also. Rest all is same. Okay. So this was about merge statement. There is nothing more to it. It again we have to do a commit and all because it's a DML. Okay. Just that it looks good. I mean it is doing two things in one go, right? So that's how it is good. Maybe I have used it, but very scarcely. Because the thing is if something goes wrong, see in real time there is bad data also. See the data into Oracle databases comes from non RDBMS databases. So sometimes what happens is, although this you must have heard about something called data warehousing and all, right? Data loaders, data warehousing. So in real time what happens is data is loaded into databases from data warehouses. Okay. Now data warehouses, they don't have any such RDBMS principles like primary key, no data redundancy, nothing like that. Okay. They will have duplications and all that. So when that data comes into a database, it might be unqualified, or it might be bad data. So in this case we need to have more control. So individual insert and updates are better than this. Okay, but if you are absolutely sure that your source data is perfectly fine, then you can go for merge. Okay, so this was about merge statement. Then there was one thing we had missed out. Create in create table, we can create a table with a subquery. This is called, they might CTAS. This this is also, you know, known as CTAS. Okay, so they, in interviews they might ask you, how do you create table as a subquery? So it's simple. I mean, uh, just like that you can create. So what is the, you might ask, what is the advantage of creating a table like this, right? How do we create a table? We give individual columns and their data types and whatever constraints if we want, right? That is how we create the tables, right? So when we create a table like this, so what this is, say salary, high salaries, okay, salary. So we are creating a table called high salaried employees, as we so whoever is earning more than 10,000, we want them in a separate table. So there is some requirement. Okay, so then we can create this table simply as select emp id salary from emp, or if we want whatever more you know columns you want, you can put it right from table employee, where we will put our condition. So this will create the table. So what is the advantage of creating a table like this? So whatever in the employee table, whatever constraints, whatever data types, and whatever restrictions were already put, will automatically get into the high salaried employee table. You don't have to again put a primary key constraint or some indexes. Whatever objects are already there, whatever dependent objects are already there on the employee table, on the selected columns, it will automatically come into your new table. So that is the, understood? Yeah, so that is the advantage of using CTAS, create table as select. Okay, this is a very common question in your interviews. Okay, then there was something that we missed out in delete, drop, and all. Okay, so insert, update, delete. As well as, leave, insert, update. We had discussed drop, we had discussed delete, we had discussed truncate, right? All these, what all these do? All these remove data from the tables, right? Drop removes the table itself with the structure also. But what I want to do is, I just want to remove a column. I don't want to remove the whole table. I want to remove a column along with its data. What should I do? I should pro- Doesn't work. Drop, you cannot drop a column. You can drop a table, right? Column is not a, not an oracle object. You can only drop objects. You can drop table, you can drop indexes, you can drop constraint, you can drop procedures, functions, and all these, which are oracle objects, db objects. Those you can drop. Column is not a individual oracle object. Okay, so you cannot drop the column. What you can do is, this is what you can do. There is a an option of using this particular keyword, set unused. Okay, so you can use a statement, alter table emp, set unused manager id. Okay, so that what it will do is, from that very moment, that column here, in this case manager id, will not be visible anymore in that table. Okay, but that doesn't mean it has been dropped. It is not visible, it is not showing to whoever is querying the table. Okay, how will it be dropped? It will be dropped by this statement, drop unused columns. Okay, so you are working, you are in a, you have opened a session and you are working. You find that okay, fine, I don't want this column anymore. You uh, no, you make this alter state, make this alter, okay, and then leave it like that. Then after all your work is done, you run this. Now this will permanently drop the column itself. So what is the difference between this and this? Alter table, uh, exactly. So it, that means it will still be occupying space in your database. It is still there. It is made invisible, but it is still there. Yes. But here the space is also freed up. Okay. And this will work for, say, someone else has made the similar alter. Someone else has made a set and used for a similar, I mean, some other column, some other table. That if you do this, that one also is gone. Okay. So it is basically cleaning up the database. So you can notice here we are not using any particular table, right? We just do drop unused columns. That means all the all the columns which have been marked as set unused will be dropped, irrespective of whichever tables they are in. Okay. So basically this is done by DBAs. Okay. This part is done by DBAs. This you can do. I mean, you can also do this. You can also do this, but this is basically hmm? Database administrators. So whenever there is a database, mhm, mhm, there is no way of canceling this. You have to again alter table and add column. Okay. Alter is what kind of statement? No, 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 no. Is it a DDL or a DML? So can it be rolled back? It cannot be rolled back, right? So you have to physically add the column once more. Okay. But only after you have dropped it. Otherwise, it'll become inconsistent, right? It will not allow you. It will say that the column already exists. The name, that is. Okay. This is clear. Set unused. This is a very important aspect of Oracle. Very few people, I mean, only after working for 4 to 5 years, people get to use this or get to know this. Okay. Then there was something that we are asking about updatable views, right? We had discussed views. Views are Oracle objects which fetch data from the underlying tables. These are basically constructed as a select query, and they fetch the data from the underlying table or tables, and they will always give you the most recent data. They don't occupy space, and we can customize the view according to I mean, there are like 500 column 500 sorry, there are 50 columns in a table and we only need data for 20 of them. So we can have those 20 columns created in a new view, and every time we need to query that, we query the view instead of the table. Okay. So those were the advantages. So there is something called updatable view, there is something called non-updatable view. So what do you mean by updatable view? You can update a table, an underlying table, from a view created on it. You can do that, but that can only be done under uh, very few conditions. What are those conditions, right? So we create view. We can use something like, let's create this as a view. Okay. View as so this will create a view. right? So instead of, we can select star from high salaried emp. Now, one of the employees, update, I, whatever, I'll just copy this. Yeah. Set sal equals to 1.2 underscore sal. That's all. What will this do? Can you guess, or can you understand what this update statement is doing? Yeah. So everyone is getting a 20% hike. Okay. Right. But when we are updating here, what will happen to the original table employee? We are updating the view, right? We are not updating the table. Original table is employee, right? So there is a, while creating a view, there is an option, updatable. Okay. I think it is with updatable option, something like that. Okay. So if you create a view with this keyword, the table here, so the table will also be updated for those particular employees, only for those particular employees where salary is greater than 10,000. Okay. In this case, yeah, in this case, the employee table will also get updated for those particular employees. Okay. But can you see, uh, I mean, this is a simple view, right? This is not a complex view. We are only fetching data from one single employee. Yeah, if some, yeah, basically joins and subqueries, complex view. So what it means is Oracle can easily trace back the data. Okay, because there is only one table which is fetched, and there are no duplications of the emp id, right? There are no duplication of the emp id, because we must be having emp id as our what is it called, primary key. So there is no duplication and everything. So Oracle can trace back from the, generally what, first there is a table, then we can create a view. It's not that we create a view and then we create a table, right? So when we are updating a view, Oracle has to trace back to its table, to its underlying table. Here it can do that easily. Okay, that is what is called, that is what is called a key preserved concept. What is it? A key preserved table is a base table with a one-to-one row relationship with the rows in a view. Okay. So here it is key preserved. Did you understand, or you want me to? Okay. So what is our table name? Table is employee, view is high salaried employee. Okay. So table employee will mostly have more data than view high salaried employee, because we have filtered out only the people who have greater than 10,000 salary and put them in the view, right? But for that, for those people, for those employees who exist in both the table and the view, it is one to one. That means for every emp id record who has more than 10,000, there is only one emp id record in the view. So that is called a one to one relationship, right? say there is one MPID. hmm, MPID 55 has a salary, uh, 15,000 in the table employee. So the same thing will appear in the high salaried employee view also, right? But will there be another record in the high salaried employee view for the MPID 55? There will be no more records, only one, right? So that way, the there is a one-to-one relationship established between these two objects, right, in the table and the view. So when we update the view, see, when we update a table, the view gets automatically updated. So that is not rocket science. That happens automatically. Okay, because whenever we query a view, it gives me the most recent data. Okay, but we are talking about the other way around. We are updating a view. Will it, percolate to the table? Will it update the table, the base table? In this case, it will, because it can. Hmm, correct. Correct. So that is necessary, and then this is necessary. The table should be key preserved. That is, there should be a one-to-one relationship between the view and the underlying base table. Only in that case, you can the data will actually get updated. But which conditions? So this is the list of conditions where the data will be updated. So insert, update, delete is only allowed to modify data from a single base table. Here there was only single base table, right? For an insert statement, all columns listed in the into clause must belong to a key preserved table. So it's all key preserved concept. Same thing. The one-to-one relationship should be there. Basically, if you, talk in non-technical sense, non-technical words, Oracle should be able to trace back the data in the base table. Okay. Here it is able to trace back. Okay. So that is what. So there are a couple of very interesting things here. What do you mean by a key preserved table and one-to-one relationship with its view, and then how do updatable views work? When you try this, you will get even the your concept will get even clearer. Okay. So last thing we can do today is, because I have already we are going one by one. Any doubts today in today's class? Okay. So last thing what we can do is we can another chapter using set operators in Oracle. So what are the set operators? You remember, right? Must have done in your studies: union, intersect, minus, all these things, right? Okay. So these same things we can use for tables also. But there is a condition to it. That means Oracle has the following use in SQL where individual result sets. Individual result sets are considered as individual sets. Okay, not tables. Sorry, result sets. Okay, so we can union two individual queries. But the important aspect of writing a query with these operators in it is the column list should be identical. That means, so this is result set one, this is result set two, right? But what we are, yes, yeah. So what we are querying here, we are querying employee ID column, department ID column. Here we are querying manager ID column, department ID column. Now manager ID is nothing but employee ID only, right? Manager is also an employee there, and manager also has employee ID. So so there is a, yeah, manager ID is also employee ID. So this will work. Why? Because it will show the data type, there is no mismatch, right? This will work. And how it will work? say there are 100 records in employee and there are 20 records in managers. So first it will show the 100 records from the employee, and then this will be sort of appended. Okay, the 20 records from managers will be appended. Clear? Hmm. But this will, yeah, absolutely. Data type has to be same. Yeah, has to be same. Why? I mean, the second example, it will not work. Okay. Say select emp id dep id from employee union, select manager id, fine. Number of reportees, if there is a column in manager, right? How many? So it's a numeric. How many people report to him? This will not work because dep id, number of reportees, mismatch, right? It will not work. Yeah, it will not work. So it has to be identical. Okay. So you understood how union works? Basically, it will append the second. So you can have multiple. I mean, it doesn't have to stop at two result sets. You can do more result sets also. Okay, you can still have more union and then another. Yeah. So that also will work. There is no such, as far as I know, there is no such restriction. There must be some restriction, like maybe 200 and odd or something like that. Okay. So, but here what we are doing, we are considering individual result sets as individual sets, and we can use our set operators there. Union will append the second result set with with the first result set. Okay. Similarly, intersection also works in the same way as intersection of sets. It will only have the common records of the first and the second query, right? So if I, oh, it should be intersect. If I run this, what it will show? What is common between employee table and manager table? I mean, employee ID and manager ID? No, 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 no. No, 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 not department ID. So think about the data. Okay, think about the data of these result sets. So employee ID, employee has 100 records, right? So this will show you 100 employee records. Okay, manager has 20 records. There are only 20 managers. So it will show you 20 manager records. So these 20 manager records will be there in the employee records also, right? This is a subset, right? So this will only show data for the managers. So all the non-managers in the employee, this will not show, right? And the good thing is this will not duplicate it. Intersection, in the intersection, what? I mean, it only shows data once, right? Although the data is present in both the sets, it works as the common factor, right? In the Venn diagram, if you remember the middle section, it is common. Yeah. So it won't be duplicated. That means there won't be 20 records from employee and the same 20 records again from the managers. Okay. Got it? And the last one is minus. So minus, how does it work? A minus. Okay. A minus B is, so part of A which is not A intersection B. That is A minus, right? A minus B. So A minus B is what? A minus B is the part of A which is not there in the intersection, right? So in this case, only belongs to A, right? Correct. So in this case, if this is our A, so what only belongs to A? The data for employees who are not managers, right? So that we can get here. Simple. Okay. So that's all for today. The concepts, go through them. This actually we have covered. I mean, there is nothing. I did go through the syllabus. I can show you. Where is it? So we are at, we are, we have completed till 14. Okay. 15 we will be covering tomorrow. So subquery also we have completed. We have completed 16 also. So 15 and 18, sorry, 15 and 17. These two are a little complicated, so you will need complete attention. And then it is very simple. All these things, procedures and all these are very simple. Okay. So let's try to complete 15 tomorrow. If possible, we'll complete 18, 17 also. Okay. Hierarchical queries. So I would suggest you do some practice, okay, with the group by, and whatever exercise I have given, just do some practice with that. Okay. Okay. So meet you. I'll meet you tomorrow. Okay.